dealing with more primality testing based on contrived numbers here. Now we have this huge number, about what, 1/8 of a million, 124 million, and a bunch of large number. Let's put it that way. We're supposed to do this without technology. Now, you'll notice, or actually the problem's just designed to work, let's be honest. But if you carefully look at it, you'll notice it's in this form right here, this a cubed minus b cubed form. The cube root of 125 million is 500 cubed. Okay, and that's, again, that's by design. And then 7 cubed is 343. So when you subtract the 343 from this, you actually get this number that we're trying to find a single prime factor. So let's be honest, these things are designed to work. You work backwards to create a problem that looks like it came from nowhere. But in any event, here's the well-known identity, a cubed minus b cubed. And here it is for you to use. In the course, a is equal to 500, b is equal to 7 in this particular case, 500, 7. So 500 minus 7 gives you 493, plus this massively large number. Now, y'all, here's where the joy of the algebra comes into play. What we have going on here, you might think, well, you got to go further with this, but notice we have a number here that looks like it's almost prime. You know, 493, it's not a multiple of 2, it's not a multiple of 5. The sum of its digits isn't divisible by 3. So this is looking pretty good. And so we don't even really, if we can make some progress with 493, we don't even have to care. We don't have to know how to pronounce this number. Okay. So we're going to pick on 493. And there's a pretty well-known result from number theory that you can check all the numbers up to the square root of the number you're interested in. In other words, and if there's none of those are prime divisors of the number, then the number is prime. And as I said earlier, it's clearly not a multiple of 2, a multiple of 5. 3 doesn't work. Now 7's not quite as clear, but 7 times 70 is 490. So you can see it would leave a remainder of 3. So 7 doesn't work. 11's a little bit more trouble to check. 30 times 11 is 330. Then you can work it out and find out it doesn't work. 13 also isn't a whole lot of trouble. Let's see, I think 30 times 13 maybe, and you have to check it, but it's not hard work really. Now, if you get to 17, you'll notice that 17, let's just off to the side, hope the Wi-Fi is working good enough for this. 30 times 17, y'all, 30 times, I'm trying to write down 30 times 17, ladies and gentlemen. 30 times 17 is 510, right? So you see, that suggests that we're awful close. In fact, if you drop down by 17, you do get 493. Y'all, this is pathetic. I apologize for this. It's just the way it is in this part of the world. 510, okay? So 30 times 17 is 510, and you can see if you deduct 17 from that, you get 493. And so 17 means 17 is a divisor, and it turns out, and we just explained why 29 goes. So any one of the answers would be okay. 17, I just arbitrarily pick 17. And y'all, by the way, we don't know 17's the smallest. Maybe this number has something going on that's less than 17. We don't know. We don't care. We were just asked to find one prime. So either 17 or 29 meets the criterion here. I like that one, folks. Big old number. We use the power of algebra to find out its smallest prime factor, 17.